Hello, this is a tutorial screen video for the DLT Data Viewer 2 program, recorded by Ty Hedrick on January 18, 2007. This tutorial deals with the 3D recording features of the program, and all the data files used in this demonstration are available for download from my website. So having started MATLAB, let's go ahead and fire up the program. Having started the program, we'll go ahead and initialize it with the demonstration data. We know that there are 3 videos, and we can load them in sequence by double-clicking on them, one after another. We could also highlight them and click Open. The cameras are also calibrated with the DLT coefficients file that's been provided. So we'll click Yes, and then open the coefficients file. Now we're through with data initialization, so let's take a look at some of the different features of the program that relate to 3D kinematics and multiple video files. First of all, we have frame offsets, in case our video streams are out of step with one another. So by adjusting the frame offset of frame 2, which is in the upper right-hand corner of the videos panel, we'll jump that frame ahead relative to the other 2 that are unchanged. We can do the same for the third frame, and both of these motions are relative to the first frame, so there's no need for a separate offset for that. If we had a fourth video, we'd also be able to control its offset. In this demonstration data, the offsets should be 0 for each case. Alright, moving down the interface, we have the usual frame slider and frame number entries so that we can move through the video streams. And we also have the current point interface so that we can digitize multiple points in a single trial. We also have an auto track mode, similar to what was shown before, though as this is a slightly newer tutorial, the options are somewhat different. And there's an additional thresholding option for the direct linear transformation, or 3D residuals. But let's zoom in on the bats shown in this video and take a look at how the 3D digitizing works. So, as usual, we're zooming in by positioning the cursor over the area of interest and using the plus key on the keyboard. We could zoom back out either using the minus key or tapping the R key to restore the video to its original aspect. Alright, we see that the bat swing is marked with a large number of white dots. Let's go ahead and click on one. Once we click, we see that a number of things happen. First, a red circle appears exactly where we clicked. Secondly, a blue line appears across the other 2 video streams. This blue line is the DLT visual feedback, which we can turn off with the checkbox over in the interface, or of course turn it back on. And that blue line shows all the regions of 0 error for that in the other video frames. So if we click anywhere on this blue line in video frame number 2, we would get a 3D reconstruction of that point with 0 residual. If we were to, and we can see that the line does pass through the marker, indicating that our cameras are relatively well calibrated. Over in the controls interface, we see a zoomed-in view of our point, and we realize that it's not particularly close to the center of our marker. We also see that our sort of postage stamp-sized image of our marker is fairly tightly zoomed in, and most of the tracking tools will do a better job if we zoom out a little bit more by changing the search area size and clicking again. We notice we're still not very close, but having clicked again, we can use the I, J, K, and M keys to nudge the point to the right and left, so by half a pixel each nudge. So I've used I, J, K, and M to nudge our crosshairs in the controls interface closer to the center of the dot. We could also do centroid finding by enabling it in the interface, setting the color to white for our white dots, and clicking in the region of our point. The centroid finder takes over and automatically adjusts our click to what it perceives to be the center of the white dot. So now that we've clicked in one of the video frames and gotten our blue line of 0 error, we could click in some of the other video frames. If we click on the appropriate point, again with the centroid finder enabled, we get a full 3D reconstruction. And that's shown by the appearance of the green diamond in the 3 video frames. The green diamond shows the ideal location of the 3D point that's been constructed by the 2 different 2-dimensional clicks, shows the ideal location of that point in the different video views. The degree to which the ideal location in green and the clicked location in red disagree is a measure of the error. Another measure of the error is the DLT residual shown in the controls interface. So for instance, if we were to delete that click in the second video frame with a right click to the mouse button and, say, put a mark down in an inappropriate location, we see that the red circle and the green diamond disagree a great deal, and the reconstruction residual is very high. So putting it back in the appropriate location, we see that we have good overlap and a relatively low residual. We also see that the point is correctly positioned in the third video frame, even though we haven't clicked on it. However, clicking in this location will give us a better estimate of the true reconstruction error and may or may not improve the residual, but will give us a better estimate of the actual residual, or the actual disagreement between our different clicks and the location of the actual location of the point. So now let's move on to auto tracking, something you've seen before. We have different auto tracking modes. One of those is auto advance. So for every click, the program automatically steps forward one frame without attempting to find the marker in the next frame. We can change it to semi-automatic, where for every click, the program steps ahead one frame and attempts to identify the location of the point in the next frame, based on a predictive filter and a cross-correlation of the image, followed up by the marker centroid detection, if that's enabled in the interface. And in semi-automatic mode, we can simply use the F key to step forward frame by frame, moving through the video sequence. We can also set it to semi-automatic mode, to fully automatic mode, at which point it will go through as rapidly as possible. If in semi-automatic mode we notice that the program is in error, we can tap the X key, and that will toggle through the auto track mode menu, stopping the auto tracker in its tracks. We can also use the X to switch between any of the different possibilities in sequence. So if we go back to automatic mode, that will work well. And let's go ahead and digitize the rest of the sequence here. Now, of course, we're digitizing only one view at a time here, and to get our 3D reconstruction, we'll need to go back to frame 2 and start with one of the other video streams. And in digitizing the second video stream, we have the same options and an additional threshold. So, of course, as was explained in the previous tutorial, the auto tracker continues on when the auto track fit exceeds the auto track threshold. In the 3D case, there's also a second threshold, and that's measuring the DLT residual. So in this case, the auto tracker will continue on if the fit is above 9 and if the DLT residual is below 3. So that will work fine if we're clicking on the correct point. Right? We should be able to automatically search through the entire sequence. However, that wouldn't be the case if we stop the auto tracker and then start tracking an inappropriate point. So if we track this point on the trailing edge of the wing, the auto tracker won't function, because even though our auto track fit is considerably higher than the threshold, the residual is far greater than the threshold. And that concludes the features that are specific to 3D tracking. We can quit the program, and of course it'll ask us to save our data, which we would be able to reload in the interface if we so desired. Thanks for your time, and I hope you found it informative. Again, the data files used in this demonstration are available for download on my website. Have a good day.